Hello everyone, so we are about to solve the maximum subarray problem from LeetCode Blind 75 series. You are given a nums array, the subarray with the largest sum, right? And you need to return the sum. So let us suppose this is the nums array and the subarray 4 minus 1 2 1 is its sum is 6, which is the largest one, so you need to return that. So what is the subarray? Basically subarray is a continuous array inside another array. Let's see the approaches to solve this question. Approach number 1, that is the most basic one, that is brute force. So the brute force approach says that you need to use for loop and find out all the subarrays and find the sum. So we'll take a current sum and then again we will iterate to each and every subarray and get the sum, and here we'll take the maximum. But of course the time complexity is O of n square, so we need to optimize it a little bit. The approach 2 which you can do is by using the divide and rule. Okay, what you need to find out is you need to find out the maximum of left right subarray. I'll explain you in more detail. That is, we'll make this function. I've named it as maximum subarray helper. Take the nums array, a left pointer which is on the extreme left, a right pointer which is on the extreme right, and if left pointer crosses right pointer, then you need to return the minimum value. Okay, now you find out the middle index of both the left and right, and left sum, right sum, and current sum will make these three things. Now the current sum, now first of all we'll iterate from middle to we'll start from middle towards left. Okay, so if this is the array, then we will, I'll just narrow it down to 1 2 3 4 and 5. If this is the array, so let us suppose this is the mid, so till here you'll get the left sum, from here to here you'll get the right sum. Then you need to return a recursive call you need to make and find the maximum of left to mid. You need to recursively call this, and again recursively call from mid plus 1 to right, and also meanwhile you have to compare it with left sum plus right sum. Basically what are you doing is, let us suppose your maximum amount or maximum array sum is lying somewhere inside whole, like you are covering all the left, right plus nums, so this will give the answer. If your maximum amount is, let us suppose this is minus minus, right? So here your maximum sum is lying on the right hand side, so this one will give your answer. And if vice versa, if your maximum sum is lying in the left hand side, so this will give the answer. So this is the that is why we are making the recursive call here. But I think this is also too complicated, and recursive calls add ons to the complexity and also make the problem take more time, right? So we'll use Kadans algorithm. So what basically it is basically taking the sum at each and every point, but because we are including the negative numbers here, so there is a twist. Let us take, this is a very simple and easy problem. Let us take the sum as 0. Basically these problems teach you how to use Kadans algorithm. So now what we'll do, we'll just add sums I. Okay, adding the sums total. Here we are just, this is simply we are just adding each and every element, but if sum is negative, then just make sum as 0. Okay, and meanwhile here also one thing you need to do is int answer. Answer will not be sum, but answer would be maximum of the sum, right? Because this is what we require. So math dot max sum comma the previous answer, and we'll just return answer. The maximum answer can be -2, so integer dot min value will take, right? So now submit this. Yep, we are done. Thank you everyone.